Hello, my name is Khaled, a CEO and co-founder of LabsCubed. This is our story. So LabsCubed started 9 years ago, going into 10 years now. It started when I was doing my master's. I was really passionate about trying to do something interesting with my degree in engineering. And after I finished work in Germany, after my undergrad, I decided to do a work in crash safety for vehicles. So I came back to the University of Waterloo here in Canada, just outside Toronto, and I started doing a master's in material development because that was an extremely important part of car safety. And so that was something that I had to learn that was brand new. In undergrad in mechanical engineering, we learn about materials, but it's very surface level. We do some testing in a lab, but again, it's just, you run 2-3 samples, that's all the learning you do, and then you're done. And so when I got into my master's, I realized that to create new and innovative materials, to create materials that can really change entire industries, it takes decades of development and work. A lot of manual testing, a lot of manual processes. And I sat in the lab myself for the next 2 to 3 years in my master's, just sitting there testing, repeating testing. And we had to be we had to create really good data in our tests because we were using them in simulations, meaning anytime there was data discrepancies or issues with even past data from previous master's and PhD students, or even from industry that we were working with. So we were working with large automotive companies, large material companies who were giving us the new materials they were producing, and the automotive companies were seeing what we were doing so they can potentially implement it in their future vehicles. There was a lot of data discrepancy across all these different platforms and these different labs. And so I spent a lot of time also redoing tests from other folks, previous folks, and from industry folks to make sure that it all aligned. So my simulations would become more accurate. And so I spent a lot of time doing thousands of samples in a lab and very manually, and it got really tedious. And so I started looking into automation. So I was tasked with going to look for automated tools. What we found is the ones that existed from some amazing now competitors, but back then manufacturers that we were looking at, they were very expensive, very complicated, very rigid in what they could do. They weren't able to be modifiable, etc. And so they really didn't fit what we needed. And so we kind of started this concept of, can we build equipment that's easy to use, that's affordable for material manufacturers so they can make materials faster. So really in the end, our goal is that these new and amazing materials can make it into the things that we need as quickly as possible. Better battery technology, safer vehicles, better airplanes, better tech in terms of your phones. All of these have huge amounts of material work that's required. And it really just started out of just, we were sitting around talking about these concepts, a whole bunch of engineers, which is usually what it starts with. I actually remember how we came up with the name LabsCubed. We just sat in a classroom, big board, and we sat there between myself and the co-founders, and we kept writing different names and different things and looking up if they existed, if the URL was bought up, if the company name was already registered. And we spent 8 hours just trying to figure that part out. And we thought that was the most important thing. And that was kind of one of the first things we started with. And then we were lucky, we have an incubator here in Kitchener, Waterloo, called Velocity. And it's connected to the university, but it also has a ton of amazing hardware folks that have come out of BlackBerry, which is a company that was created in our region, that have come out of ATS Automation, again, another large hardware manufacturer that builds automation and tools. And so these people were not just very knowledgeable on the engineering hardware side, but they were very, very knowledgeable on the business side, which is something that we all had to learn. All the co-founders have backgrounds in engineering. There's no business, so we had to learn that process. And one of the first things they made us do when we first started the company is go and talk to as many customers as possible. We weren't allowed to build anything, we weren't allowed to make anything. And I'm very thankful for that period of time because it really allowed us to hone in on where the pain points were for customers. We went and talked to over 300 different customers, saw their labs, went through as much as possible. And through that process, we really started to learn there is a pain point here. There is something around mechanical testing in terms of what we would tackle first, and that automating it would really be a big benefit. And so that's kind of how the company got its start. After those 6 months, we kind of honed in on we're going to build automated tools in the mechanical realm in terms of mechanical testing, so physical destructive testing. For the materials industry, we were still very wide. And so we started to try to get more specific. and we looked at the polymer industry and the metals, and we broke down all the different materials that we can go after. And we thought polymers was kind of the place to be. There's a lot of activity happening, it still is happening in polymers, but even back then, 9 years ago, whether it's recyclability, green materials, 3D printing, all of that is very polymer based. And so we thought it was a very exciting place to be. We have a big rubber manufacturer here in town called Airboss of America. They have a huge facility, and they were doing a random tour one day and for people to come in and see their manufacturing facility. So I went on this tour. I left the tour, which I probably shouldn't have done, and I went to find the technical director. We had looked him up beforehand and told him our idea. At that point, there was really nothing. It was just an idea, a concept, a development. So we built our first prototype, looked like an engineering project from a university effectively. We took it in, it worked some of the time, not all of the time, but the concept was still there and they loved it. And they really helped us to develop, and that was clearly for us like rubber testing, rubber tensile testing, tear testing. So we kind of figured out that for a lot of folks is a big pain point. And so we decided to build the best rubber tensile automated system. Specifically, the goals are very simple and they still hold true for the company today. We need to make it easy to use. The innovation kind of has to be in a black box so people don't have to worry about it. It's not something that needs to be tended to or taken care of. It does everything that it needs to inside. The easier it is, or the easier it looks from the outside, the more innovation you kind of have to pack in. And that's really what we pushed for through the process. And that was kind of how we got our start. And then we took years and years of development from that point of that first conversation with Airboss to getting something that we believed was production ready, that customers would be really happy with, that we would be happy stamping our name on and getting out the door. And that was about 3 years of development, with an addition of more years of development after the first machines got shipped. And you learn a lot from those first machines that go out. Those customers were absolutely amazing partners that worked closely with us. They knew they weren't getting a full thing in terms of like it was perfect, but they were willing to work with us because the idea for them was what they were really bought into. Those 3 years of pure R&D development, we learned a lot. We kind of reinvented a lot of the different components that existed from the ground up. So we didn't want to just copy paste and just kind of be the same as everything else. We wanted to improve things, but not just for the sake of changing them, but because it would be better. So that's always been our thesis as well when it comes to engineering. We don't just change things for the sake of changing them. If it makes sense and it improves the process and you come up with something that's really amazing from a customer perspective, then that's what we strive for in everything that we do. And that was kind of the story of the first machines. Obviously within there's a lot of trials and tribulations, ups and downs, things we learned the hard way. Through that process, we got close to multiple times where it was existential as a company, trying to figure out what's going to happen next, how we continue to grow. And so it's been an amazing journey throughout that. After we kind of got our first foothold and our first rubber machines were finally ready, almost production ready, because I think there's just not as much innovation at that time in that space. So we got a lot of excitement. We even got our next sale at a trade show, which we've never replicated again. So that was kind of a one-off. That was my expectation from that point on, but it's never happened again. But we've gotten a lot of sales after, but never during a trade show where we met with the folks. They came back day after day in terms of more people from that company, higher and higher ups, until they just gave us a deposit at the show, really kind of looking for new things, new innovation. And that's what the direction we're going in. And now we've expanded in terms of our rubber product across all of North America. We work with Hexpol, for example, one of the largest rubber compounders. We work with Bridgestone. We work with a lot of really large companies where they bought multiple machines. And I think that's testament to the fact that the machine works great, because you wouldn't buy it once and then buy it again and again, unless it's something that's really meeting your needs. It's really hitting that target of usability and serviceability, et cetera. So it works great and they love it and they use it every day. And we obviously didn't stop there. We're always striving for what's next and what comes after. We've now expanded into the plastic side. So that again was always our aim, but we wanted to concentrate at the beginning, get really good at what we do in terms of rubber. We always could have expanded earlier, but I think the more you take on early, the more you're just kind of good at everything. We want to be great at everything that we do. So if we give every piece its time, then we can really get there in terms of making customers happy. So again, we started rubber, and now as we expand into plastics, that's expanding quite quickly. And we're starting to expand our capabilities in terms of different tests and different capabilities within the machine to make it more robust, to make it be able to do a whole bunch of things that it never did from the get-go. And this is all learning. This is all stuff that we're learning along the way. We've We have an amazing engineering team that's obviously behind me that's doing some amazing work. They make me look good in terms of like what we've built and when we try to sell it, and make the sales team look good. And there's a lot of innovation, although you can't see it within the machine, that's constantly changing. And so we've used, for example, a lot of our innovation really comes from learning the pain points of technicians and folks sitting in the lab. When we go sit with them, watch them, we see what they do to have to make the machines work. For example, the grips. In a traditional system, a lot of the times technicians will actually end up having to modify them, put in sandpaper, do something so that samples don't slip, there's no issues, they're pulling perfectly. And so they actually do a lot of work just to make each sample work, and it's very manual for them. And so from the get-go, we built very smart grips, and we reimagined the entire grip process so that samples don't slip, that you get perfect tests every time. And these are things that we only learned because we watched technicians and we saw their pain points. And this goes into everything, the extensometer and the vision system, and how we measure elongation and how people stamp. So at the beginning, we had people, for example, marking the samples. That's how our competitors also work. It's a marking system, usually a marker and a stencil, and you have them mark it. Obviously, that's a very manual thing. We decided we wanted to make it more of a stamp process. So we had to reinvent the ink and work with a fellow that actually came out of Xerox to create a whole new ink that took 2 years of development just to make that perfect and make it work. But again, it's that attention to detail that I think is important when it comes to making something that's easy to use and almost imperceptible in terms of from a customer perspective, because it just looks like you just put it in and it just starts, and that's the goal.